Okay, here's another question you might get as a financial analyst. What is the average on and off peak real-time fuel mix on the New York ISO grid? So let me explain what that means. The New York ISO is, that's the ISO is independent system operator. So this is who operates the electric grid in New York State. So real-time fuel mix, what we mean by there is on the New York grid, how is electricity being produced? Is it being produced by, and it's going to be a mix at any point in time. It might be like 20% hydro, 30% nuclear, 20% natural gas. So we're looking at the sources of how we're producing the electricity. Now, what on and off peak means is on peak generally means working hours, and off peak generally means not working hours. So the idea is in working hours, people have their computers on, factories are running, and so the demand for electricity is much higher. When people generally aren't working, this is the weekends or at night, demand for electricity is lower. So what we're looking at is saying, okay, when demand for electricity is high, how are we producing it? And when demand for electricity is low, how are we producing it? So this here goes into a little bit of the natural gas. Usually, and anytime you get a question like this, you generally have an idea of what the answer should be beforehand. Base load this is like the always on sort of, this is nuclear and hydro. And then as demand goes up, we start turning on intermediate, which is like a lot of natural gas. And then we as demand gets really high, we turn on what are called peaker plant. These are very inefficient, so they generally, like fuel oil, is what I have here. It's very often what they are. So what we expect is on peak, we're going to see more natural gas. Because we're looking at averages, we shouldn't see, we'll see fuel oil, but we should see, slightly more natural gas, more fuel oil. What we should see is less in proportion of hydro and nuclear when we're on peak. When we're off peak, we should expect more hydro and nuclear. Good. So that gives us an idea of what we're doing. So we're going to do all our imports right up here. So we're going to use Pandas. And we're also going to. So we're somewhat familiar with Pandas. We're going to use OS to interact with our operating system, and we're going to do some plotting and handle zip files. I'll explain these as we use them. So we can get. So I'm importing those now. We can get the present fuel mix here. This is going to be sampled at the 5-minute frequency for any particular day. So this is going to be the URL where we put the year, month, and day right in here in the URL. Now, one thing that we're gonna do here is when we pull this data, it's going to be pulled as a zip file. So what we're going to have to do is handle a zip file. So the first thing to do is. And I have a little bit of two ways to do things here, just to show you how Python complements other methods of managing your file system. So what we're going to do is we're going to have to create some directories and so forth. And you might be used to doing this by just, if you're in Windows, clicking, like right-clicking and saying new directory or new folder. And what I'm going to show you here is maybe the Linux way and then the Python way. So the nice thing about Python is we can use it to interact with our system. We can use it to create directories and so forth. We don't need to interact with the operating system outside of Python if we don't want to. So remember, this is just a bit of a review here. We're on a Linux system, so we can see that we're in this content folder. And then what else is in this content folder? Sample data. This I haven't run this, so this should just be there. Good. So what we're going to need to do is create a new directory, right? And we can use the makedir command, which is a shell command. Now I should have here. I'm going to run the Python one, right? So let's. So what I'm going to do here is let me just run the Python. So I can run it here using the Linux, but I'd rather defer to using the Python method. So right now, if we look, we just have sample data, nothing there. So let me go ahead and run os makedir. Now this says this is my present directory, and create a folder called raw data. So once I run that, now I should, and I have this new directory, raw data. Good, we actually don't need this. I'm going to delete this. This just does the same thing. So if you want to, again, this is just to see this OS module that we brought in. You can look at all, we can make a directory, we can remove a directory, and all of that is going to be in here. Good. So now that we've made our raw data directory, this is where we're going to download the data from the New York ISO. So again, we could, if I was just to do it with a system utility, a Linux system utility, I would just use wget, and this would be the command here, but we don't have to. In Python, we can just use this URL retrieve. We can request. This is from the URL library. So the first thing I have to do is say, well, look, what year and month? Let's say we want this September 2020, 202009. And that is going to be put into the URL here, and then, pardon me, I want to scroll this right. So that's going to be put into the URL here, this plus, because all of this is strings, is going to concatenate it. And then it's going to download it to a zip file within raw data called 202009 data.zip. Right? So let's go ahead and run this. And there we go. We've downloaded that to raw data 2020 data zip. If we want to look, we can, I'll go up here and I'll say raw data, right? And we should see the zip file in there, right? So it's we downloaded it. Don't worry about this. The New York ISO was down at some point, so I just put the data on GitHub and I was downloading it from there, but we don't have to worry about that. Now, one thing here, let me just say, this, you feel free, so this Colab notebook will always sort of stay the same. I'm not going to change this much. So when you get this, feel free to add in a bunch of cells. So if you're working on this with your own version of this Colab notebook, feel free to change it as much as you want. You can always get the original spreadsheet from this URL here, but you want to save this as your own and make sure that you're trying, pausing the video, try things out to see what happens. Try to create other directories and so forth. Okay, so now what we have to do is we have to unzip this file, right? And again, if you're used to Windows, you would go in and maybe right-click it and unzip it and so forth. But again, this is manual, right? But we want to create a script that we can just hit go and it'll do everything for us, right? So we want no manual intervention whatsoever. And we can easily unzip the file using this code here. So again, this just, actually I don't need this. I already defined year, month up here. But what we have here, the relevant line really is this extract all raw data, right? Well, this is going to say extract all to raw data, right? So now with here, this is what is called a context manager. It's not terribly important, but what this does is if there's an error, it'll handle the closing and the cleaning up. So we have this with, this is our zip file, right? So with this zip file as zipref, extract zipref to raw data. Right. So what I'm basically saying here is there's a lot of things where you want to get up and productive with Python code. This is a way to extract the file. You can read more about context managers if you want, but it's much more important that you're productive now, and then you can kind of, like I said earlier, come back and fill in the gaps. But this is going to go ahead and extract, unzip the file, right? So now if we list raw, now this would be the equivalent command at the bash shell is just unzip, right? Now, if we look at this, we extracted it to raw data, right? So we should see all these CSV files that we've just extracted. Now, unfortunately, we also have this zip file here, right? So what we can go ahead and do is say, because what we want to do is we want to merge all of this. However, I don't want to tell Python to merge these files. What I want to tell Python to do is just merge everything in the directory. Right? So what I need to do is I need to get this out of the directory. We don't need it anyway. And once I get rid of this, I can just tell Python to merge everything here, meaning import it all and put it into one big data frame. So we can use our sort of system utilities package again in Python to remove this file, right? So go ahead and remove it, right? And now it shouldn't be there. Good, not there. So what we can do now is just say merge everything. And it's common, or maybe good practice, to create separate directories so you're not mixing everything up in one directory. So let's make a new directory called merge data, right? Well, in merge data, and that's going to be the particular month that we're merging. So we can merge that, and now if we look in merge data, right, then we have 2020-09. So now we have a directory that we can put all this stuff once it's merged. So now it comes to the meat of taking all of these CSV files and appending them into one big data frame, right? Now, all of these CSV files are the same insofar as they're structured the same, they have the same columns and so forth, they're just different days, right? So this is going to be the code that is going to put these into one big data frame, and I'll walk through it a little bit. So remember, we don't want to have to say list each file. We're just going to say merge everything here. And this gives us everything there, right? So, well, I'll go ahead and run this and then talk about it a little bit. So what happens is, maybe it's a bad variable name, but this is going to be a list of all the files in raw data. So OS lister is just going to say, just give me a list of all the files in raw data. And let me go up to the top. You know what? I tell you what. Let's separate these out. All right. So I just want to print that, and then let me add another line, and I'll print that in a second. So this just lists every file in there. So now I have a list of all the file names, right, stored in FF. Then I create a new list, and I say for I and all the files here, so for each one of these, right, I read it in using read CSV. So for this one, read it in using read CSV, and then append it to fuel list. So it starts as an empty list, and then what it does is it reads this in, appends it, reads this in and appends it, reads this in and appends it. So what we have there is a list of data frames, right? So that may not make sense, so let's look at it. What is this thing? Well, it's all the data frames put together into a list. So this is one of the data frames, 2,079 rows by 4 columns, 2,065 rows by 4 columns. There's different 2044 rows by 4 columns and so forth. Let me get up to the top here. So now, again, lists are, we're kind of used to this is a list of file names, or we could have a list of numbers, but lists can hold other things. Lists can hold data frames. So that's what we have here. We have a list of data frames. And so to kind of show you, well, first we can check the list of it and say view list. Yes, it is a list. And because it is a list, we can just say, give me the 4th entry, right? And so this shows us the 4th entry in the list is this data frame, right? We can sit here and give me the 10th entry, right? So this is the 10th entry in the list, another data frame. And we can check and say, okay, well, if I just take the 4th here, what is this? What type is this? And it shows it's a data frame. So what this shows is that view list is a list of data frames, right? And that's fine. The only reason, again, we do that is we create a list of data frames here in view list, and then once we have a list of data frames, we can concatenate them all together by just calling pandas concat on this list, and it'll concatenate it all together into one big data frame. So if we want one big data frame, the basic workflow is get all the list of all the files, read each file into read each file into a data frame and a list, and then once we have a list of all these data frames, concatenate them all together. So that's what's going on. And remember, if you're looking at this, just kind of break it apart into pieces and it becomes easier to understand. So now we have a list of, now we created that and then we concatenated them all together into one big data frame called fuel, right? So we can look at this and we have 61,670 rows, 4 columns. So we've stacked them all up, basically. Now notice the indexes here. We're going to change these indexes because the indexes they still maintain their same indexes even though we've concatenated them all together. We can do a little preliminary and check the shape. We can check the types, object, fuel category. This is the amount of, so talking a little bit about this, this is the time, and we have to convert this into time because right now it's simply a string. Time zone we don't really need. This is the fuel category, which is a string, and this is the amount of megawatts generated. Right, so generated megawatts, right? So at September 9th, 2020, this was like between 12 and 12:05 in the middle of the night. We generated 4,014 megawatts via dual fuel. Okay. Good. So the first thing we need to do, and it's really common, a lot of people sort of starting at this overlook in it, but when you have times, you definitely want to convert them to a type time so that you can operate on those times, right? So we need to tell Pandas that, hey, this is a timestamp, so that we can then manipulate the data according to time, right? Now Pandas is great because in traditionally handling time can be frustrating, but Pandas makes it easy. So what we're going to do here is we're going to take this fuel timestamp column and we're going to convert it to a date time, and then we're going to assign that to the fuel timestamp. So we're going to overwrite fuel timestamp as a date. So we can run that, and then we can check the types, and right there, good. We have timestamp is date time. Right? So that was successful. But now what we want to do is we want to use that as the index for our data. So up here we have the index of numbers, which are meaningless here. We want to use timestamp as our index. So what we can do is we can set the index, so we can manipulate the large data frame based on this index. We want to set the index to timestamp, and in place is true, right? And then we want to drop the original timestamp column because we don't need timestamp as an index and a timestamp as a column. So there we go. Now we can take a look at it right now. So so what you should see is now we don't have this index over here. We have, this is our index, and then these are our columns. Does that make sense? So we can also, take a look, and it says we have 3 columns now because we've converted one of them into an index, right? Whereas before we had 4. Right? So now, once we do that, however, we can split this data frame fuel up into 2 separate data frames based on the time. So we can define this as on peak and off peak, right? So this is at night into into about 7 o'clock in the morning, till 11 at night. So we can split up the 2 data frames, and feel free in here to take a look at them, to make sure that everything is as you would expect, right? You can print the indexes of them and so forth to make sure that it divided it as you would expect. Right, so looking good. So now and this is really, it's really nice how easily in Python in Pandas you can do a lot of these calculations. So what we want to do now is we want to group this by the fuel category and calculate the average number of megawatts generated. So we can do that simply by saying group. So we'll work on off-peak here. This is our off-peak data frame. Group it by fuel category and calculate the mean, right? And then set that as the variable off-peak averages. So if we do that, I think that ran, and we can look at it. Right, so now what we should have, we should easily see it, we have, this is the average number of megawatts produced in each, for each 5-minute interval by fuel category. So again, to sort of, let me put this on to recap what we've just done here, because again, this is really nice, much nicer than if I can, say working in Excel on this. So what we've done is what this has done is it's grouped everything by, so you can set it, reordered it, grouped everything by the type of fuel, right? And then calculated the average over each type and return this nice data frame. So now that we have this, we can go ahead and now we just want to get the proportion. We want to get the percent. So we can add a generation percent column to this by just saying divide. Now keep in mind this is a column, and we're going to divide this by the sum of this column, which is just a float, a number. So keep in mind what's going on in this operation is if I take a column divided by a number, it's just going to take each element of that column and divide it by the number, right? So what we can do here is we can say, define that, and what we're going to see is a new column here. So what it did was it summed all of this up, right? And then it said 2926 divided by that sum, 2438 divided by that sum. And you can also, it's always good to check. What we can do is, it might make sense to check that the sum of this, if our calculation is good, you can eyeball it, that's fine, but the sum is 1, like we would expect. So it did work like we expected. But that's important to know that if I have a column here, right, then it's going to apply this operation with the same sum to each element of that column. So we'll do the same thing for on-peak. So this is just the same calculation. So now we have on-peak generation percent, off-peak generation percent. And what we can do is, let me get this so it's a nice data frame. So now we can sort of answer the question or start to look at the question. We have hydro here is, what is this, on peak? So we should expect this is a little bit lower. Off peak. Oh no, hydro, no, but let's check nuclear, 30. Yeah, so nuclear is higher, right? So as we would expect, as we move on peak, we use less nuclear. Hydro, that's very close. So I'd say hydro is not changing. If I were to do a test, a hypothesis test, these might not be able to reject the null, that they're the same. But what's also very useful is just to visualize them. So I'm going to this just shows a list of the index of on-peak averages. So this here is the index, right? So when it created this data frame, it set the fuel category as the index. And I can create nice visualizations of these it might help a little bit. Now, we'll have a separate whole session on visualization, so don't worry about this. We'll talk more about visualization libraries and so forth. But it's kind of nicer to see here. We can see nuclear off peak. We should expect it to be higher. It's 30%. Here it's 26%, so that makes sense. Let's see if natural gas is higher. We should expect natural gas. Where's natural gas? This is 20 and 23%, so it is higher, just what we would expect. So things are behaving as we would expect them. So we've sort of answered our question. And I say sort of because we have made an error here, right? Thinking back, off-peak was defined as 7 a.m., on-peak was 7 a.m. to 11 p.m. on the weekdays, but 7 a.m. to 11 p.m. on the weekends was off-peak. So what we've done here is we've made a bit of an error. We forgot to separate it by the weekends. So what we need to do to fix this and really answer the question is we first have to separate into weekends and weekdays, right? And then do the analysis. We could separate it, but first by weekends and weekdays, or we can do that after. However, we didn't take into account the day of the week here. So first we can do is divide the data set into weekends and weekdays and recalculate the proper average fuel mix. Now, what we can do is we can use the day of week. So this is going to be your exercise, is to recalculate this the right way. So the only function you'll need besides what we've seen here is day of week, right? And this should give an integer, right? I think this returns an integer of what day the week is. You can look at the documentation here. Right, it returns an integer of what day of the week. So we can just feed in dates and it'll tell us days of the week. So we can separate off weekends from weekdays and then redo this calculation. So as an exercise, you do this, fix this, and see if that affects, and what we should see, right, is that the effect is a little bit bigger. Natural gas might be a little higher. Probably won't have a huge effect because there's not too much, not too many of the days or weekends. But generally you would see natural gas is a little bit higher as we move on peak. Nuclear is a little bit lower.